Okay, hi guys. So today we're going to do the editorial for this Codeforces round 723. So actually, the contest is like still going on, and I can like solve two more problems right now. But yeah, so I'm really distracted because of a few other things that are going on with me right now, and those other things also ended up destroying the screencast that I was doing. I was actually screencasting this contest, so like I got really distracted due to something in between, and that something actually explains the huge gap between this C2 and D that's there. And yeah, so I really can't focus right now. So I thought I'll just do the editorial and call it a day. So yeah, so we have problems from A till D, and we'll be doing the editorials for them, and we'll be going a little quick because I have some other things that are going on right now. Okay, yeah. So in this first problem, it is like you are given an array of two n distinct integers. So yeah, so this is important that all the integers are distinct, and you want to arrange the elements in a circle such that no two like you don't have two elements such that like their average is present in between them, something like this. So it's like you have to arrange the elements like this in a circle. Do we have six? Yeah. Yeah, so let's say n equals 3, then 2n will be 6, and you want to arrange them in a way that, sorry. So yeah, so this element should not be the arithmetic mean of these two elements, and this should hold true for everywhere, like this element should not be the arithmetic mean of these two elements, and so on. So what we will do is we will first take the input, whatever that input is given, and then since these are all distinct, so then we can what we can do is we can divide this array into two halves, right? So this is the small half and this is the big half. So this all these elements that are present here, I'll call them small, and all these that are present here, I'll call them big, right? So what I want to do is I want to take I want to alternate the big and small elements in the circle. So the circle, I will, like any small element I'll denote as an S, and any big element I'll denote as B. So I want to make the circle like this, SB, 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 like this. So what is happening now is adjacent to any small elements you have two big elements, and adjacent to any big elements you have two small elements. So the thing is, if you take the average of two small elements, obviously it cannot be a big element, right? The average of two elements cannot be bigger than both the elements. And if you take the average of two big elements, it will be a small element, which is also not possible. If you take two big elements, the average cannot be smaller than both of them. So yeah, so that's what we have to do. And instead of making it like a circle, we have to like start from anywhere. So I'll just print like SB, SB, SB. And what are these S? I'll take the small elements like this, 1, 2, 3. And what are these B? I'll take the big elements like 6, 5, 4, and so on. So yeah, so like this I can do. Let me show you my code as well. So yeah, for the code, what I've done is I've taken 2n integers as input. Then so 2n integers I take input. I sort everything. Then I take two pointers. One is pointing to the first and one is pointing to the last, first and last, right? And then what I'm doing is I'm printing the first and then the last, and then I'm increasing the first and decreasing the last. So it is happening something like, let's say, first I have two pointers like this, first and last. So first I print this, then I print this, then this pointer moves here, this pointer moves here. So then I print this and this, then this and this, and so on. So yeah, so I'm alternating between small, big, and yeah, so that gives me the answer. Okay. Now I have this next problem. I hate 1111. Okay, so actually the name of this problem is like very clever, and it is I hate 1111, and 1 is 4 times here. So yeah, so the funny thing about this problem is that if you look at any number like 1111, actually let me first read the problem. So you are given an integer x and you want to see if it is a linear combination of all these numbers, 1 and so on, right? Okay, so the thing here is, if you take any number that is like at least 4 ones are there, like 4 or 5 or whatever. So if you have at least 4 ones there, then you can observe that this number can actually be formed using only 11s. So you can see I take 11 ones plus I take 11 100 times. So if I do this, then this thing will be formed, right? Similarly, if I want to form this thing, then what I can do is I can take 11 1000 times, and then I can take 111 one time. So yeah, so anything that has more than 4 ones can be formed using only 1111, using only 11 and 111, right? So if any number can be formed using 11, 111, 11111, and so on, if any number can be formed using all of these things, then it has to be formed using only 11 and 111, right? So if I can form the number using only 11 and 111, then the answer is yes, otherwise the answer is no. So yeah, so that's all I have to check, whether I can make the number using 11 and 111 or not. So it is something like I have to check if 11a plus 111b equals x has any solutions or not. A solution in which both a and b are greater or equal to 0. So I want a comma b greater or equal to 0. Yeah, so this thing I want. And if you see, it is actually a linear Diophantine equation, and you can actually get some solutions using something like linear Diophantine equation or whatever. But like, at least I didn't think of that. So what I did is take the mod of this entire equation with 111, right? So we get 11a mod 111 equals x mod 111. So you must be thinking, where did this thing go? Where did um, this this thing go? Right? You must be thinking, where did 111b go? Right? So 111b is actually a multiple of 111. So if you take the mod with the 111, obviously this term will become 0. So if this term becomes 0, we will have only these two terms. So now this is something like 11 multiplied by a equals x in the modular field of 111. So what we will do now is we will multiply both sides with the inverse of 11, right? So if we multiply the inverse of 11 on both sides, so it will be something like a equals x multiplied by the inverse of 11. So multiplied by the inverse of 11, and to get the inverse, you can use a lot of techniques. One is like, obviously you can't use that Fermat's little theorem technique, because 111 is not prime. So if you want to use Fermat's little theorem, you actually have to use the Euler quotient of 111. So yeah, so that's messy. What you can do is you can actually iterate from 1 till 110 and actually find the multiplicative inverse of 11 by linearly running a loop, right? So yeah, you can do that, or obviously there is an extended GCD method of doing it, so you can do that as well. This is all some math kind of thing. I'll just put the links to my put the links of my lectures in the pinned comment, so you can check them out. But yeah, anyway, so this way we get the value of a mod 111. So something like a mod 111 we have, right? So if we have a mod 111, what we can do is we can just assume that this is a itself. We can say, what is happening? Yeah, so we can say that this is a. So a can obviously be something bigger than that. So let's say if a mod 111 equals k. So we know that the actual value of a will be 111n plus k, right? So what we can do is we can just ignore this 111n, because we can add that n to b. So yeah, so we can just say that just ignore this and directly say that for the purpose of this problem, a mod 111 equals a itself, or you can say that a is smaller than 111. Anyway, so a is smaller than 111, you can say that, and obviously if there is a solution that exists, then a solution will exist for this condition as well. So you will have a equals whatever this thing that you get. I think it is what? I think it is x mod 111 multiplied by 11 inverse mod 111. So yeah, so this thing you get a, and once you have a, obviously you can get the b. So b has to be x minus 11a divided by 111, right? So what you will do is you will find x minus 11a, and you must confirm that this has to be greater or equal to 0 and divisible by 111. Divisible by 111. And if both of these conditions hold true, then the answer is yes, otherwise it is no. So let's see how I have done this problem. So for this problem, I have this mod inverse function. So this gives me the multiplicative inverse of the number. And yeah, so first I found the x, then I found EA. EA is actually the value of 11a. So this is x mod 111. Then I find a using 11a by multiplying the mod inverse of 11 to it and taking mod with 111. So yeah, so that's the a that I get. And then I have 111b. That's why the triple O, because it is 111b. So 111b is equal to x minus 11a, which is what we have here as well. And after that, if this thing is greater or equal to 0 and it is divisible by 111, then obviously the answer is yes, otherwise it is no. So yeah, so that's all we had to do here. I think this was a little tougher than any usual division 2b problem, but maybe there's some easier solution that I am not able to see right now. Okay, right. Next up, we have this C1 and C2. Okay, so I'll just cover both at once. How to do C1 and C2. So the idea is actually like greedy. What we will do is we will see, first thing, it is obvious that any potion that has a positive value, obviously we will drink it. So positive potions we will always drink. So let's say we have drunk all the positive potions, and in between there are some negative potions. So what should we do in this case? So what we will do is we will just take the potion with the least negative value. Least negative value means that let's say if I have a -1 and a -10, I will take the -1. Okay, so wherever the -1 is, I will find that, and I will say that if it is possible to drink this potion at this time, then drink it, otherwise leave it. Okay, so how does that help me? Uh, the idea is if I don't drink this -1, it won't benefit me in the future, right? Uh, like if I don't drink this -1 right now, what will happen is maybe in the future I can drink a -5, but that's it. Like I cannot drink two potions after that. Like if I am leaving a -1 right now, I can't even drink two -1s in the future, right? So if even if I can drink something else, it will just be a single potion, right? So if I just leave out on a less negative value, and even if I'm able to take a more negative value in the future, but I will only be able to take one of those. I won't be able to take more than one of those, right? So this is like a exchange argument. Let's say in an optimal solution, you missed out on a less negative value and took a more negative value. So in this solution, what we can do is we can just ignore this part and take this part instead. So obviously the answer will definitely be better. And yeah, so that's what we had to do in this. Yep. So so the idea is we will just take the least negative value first, or let's say the biggest value first, and we will try to incorporate it. And if taking it immediately causes a problem, like if taking it is impossible at that point itself, then we won't take it. Otherwise, we will take it and increase the answer by 1. But how will we find whether it is possible to take a value or not? For example, let's say I have taken this and this and this. Now I want to check whether I can take this or not. So to check whether I can take this or not, what I have to do is I have to check if the minimum prefix sum of all these elements is like doesn't get smaller than 0 when I actually take this element. So for example, let's say that this element is -3, and at any point if the prefix sum is 2, like if the sum of all these elements is 2, so if I take this element, what will happen is the prefix sum at this point will become -1, which is smaller than 0. That means your health will be smaller than -1. So obviously you can't do it. So what we have to do is we have to quickly be able to check what is the minimum prefix sum in all these indices. So yeah, so that's what we need. So we need minimum prefix sum in range. Minimum pref sum in range. with point updates. With point updates, yeah. Okay. So we can actually improve this and make it something like minimum value in range with range updates. How will that work? So instead of adding a certain value here, like instead of adding -3 here, what I will do is I will add -3 to all of these elements. So when I add -3 to all of these elements, what's basically happening is that all of these elements are storing the prefix sum. Like the contribution of this element in the prefix sum will be in all of these next elements, right? So yeah, so in this way I'm storing the prefix sum itself on each node, and now I just want the minimum value in range. So yeah, so that's the whole solution. For C1 also I've done the same thing. What you can do is, if you don't want to use segment tree or if you don't understand segment trees, what you can do is you can just check the minimum prefix sum in linear time. So yeah, so that will also work because this will run in n square. But I have the exact same code for C1 and C2 both. So I'll just show my code for C2. In this, what I have done is, first of all, this is my segment tree. Yeah, so this is the segment tree which helps me get the range updates and the range minimum query. Yes, so if you want to learn more about this, again, you should check out my segment tree course. The link to that also I will put in the pinned comment, along with the number theory courses. In fact, just the modular arithmetic course and this course, segment tree. Yeah. So you can check it out if you want to learn about it. So first of all, I take the segment tree. So I take a segment tree. Then I take a set of pairs in which I'm storing the negative of a value and the index. So what's happening is when I'm taking out the elements from this set, I'm taking the bigger element first, like bigger value element. So bigger value element I'm taking first, and then the smaller value element, and so on. So yeah, so if then I find the minimum prefix sum. If the minimum prefix sum is smaller than the current value, then so yeah, so this is something. This is just the logic that I explained. Nothing much. Just seeing that whether the prefix sum will become negative at any point or not, right? So if it does, then I cannot add it to the answer. Otherwise, I will increase the answer by 1 and just change the prefix sum accordingly by performing a range update. So yeah, that's what I did in this problem, and I think now all that's left is the problem D. Yeah, the problem D, actually I don't really have a proof for this one, but I can tell what I did. So what I did in this problem was, let me just comment this part out. Just a second. Yeah. So wait a second. So what I did is, let's say I take, yeah. So I used, let me just first read the problem, okay? So it's something like you are given a string and it has only 4 characters. You are given a string with only 4 characters, A and T and O. So these are the words that spell Anton. And Error Gone actually wants to kill Anton because he's rejecting a lot of problems. And I can understand his pain. But yeah, anyway. So spoiler, but whatever. Yeah, I'm actually making a contest right now, but anyway. So yeah, don't make much fuss about it. Like, I don't know, like maybe it can get cancelled if my problems are really nice, but whatever. So yeah, only 4 characters are there, Anton, which make Anton. And what you want to do is you want to kind of shuffle the string, like make a permutation of the string in such a way that it takes the most number of swaps to get it sorted again. So first of all, let's solve this problem. How to check how many, like if you're given 2 strings, one is a shuffled version of the other. So you want to find out the minimum number of swaps. Right. So let's take these 2 examples, Anton and NNOTA. So let's say if I have Anton and NNOTA. So let's say if I want to find the minimum number of moves to do this. So what I will do is I will just read this string from left to right, and whenever I get a, I will try to find the nearest A and put it here like this. So in this string, what I can do is I can just make a list of elements A, O, T, N like this, and I can store the indices of the element, like A is present at index 5, O is present at index 3, 4, 1 and 2 like this. So I can do something like this. And what I want to do here is, first I will find the earliest A, which is 5, then I will bring it back here. Then I will find the earliest N and bring it back here, like bring it forward here or something. Then I will take the earliest T and put it here, earliest O, put it here, and earliest N and put it here. So yeah, so that's the greedy approach of getting the minimum number of swaps. But how are we actually calculating it? Because let's leave this part out for now. See, what's happening is, first when we bring the A, all of these elements actually get shifted towards right by one step. So how do we keep track of how many times whether an element has been shifted right? Because like this, you will think that it will take one swap to actually bring this N here, but it won't, because when we brought this A here, what happened was it became like N OT, A N and OT. So this A N is already at the point. So yeah, so to do this, it is simple. We just need some data structure, like let's say segment tree or Fenwick tree or something like that. And what we have to do is, when we bring this N to somewhere, like whenever we bring this N to any point, we just have to see how many elements in this range are already brought to some place, like how many of these are already used, because whatever of these are used, they will be sent towards the left of the, whatever element we are considering. So we just want to know how many elements in this range are actually gone back or are actually used. So you can do it in a lot of ways. You can use segment tree, you can use Fenwick. I use Fenwick, by the way, but also you can use ordered set. So yeah, so ordered set also you can use if you know about that. So yeah, so using ordered set, what you can do is you can kind of count how many elements are smaller than a certain element, or how many elements are bigger than a certain element in a set or multi-set. So yeah, something like that you can do if you know about it. Otherwise, you can just use a Fenwick or set tree. I use Fenwick for this problem. Yeah, so that's how you can actually count how many swaps it will take to sort two strings, right? So I have this Fenwick. I also have a function to clear my Fenwick. But anyway, so this is the function that does what I just described. Does what I described. So this function takes two strings, S and T. T is the shuffled version of X. T is the shuffled version of S, and then this will check whether it is possible to kind of swap, like what is the minimum number of swaps that are required to make T into S. So yeah, so that's what this function is returning. And I have done exactly what I told earlier. So that's what I've done using Fenwick and everything. I won't go over this, but yeah, so that's what I've done. And after that, what I did in this problem was, I took any string, I first sorted it. Okay, after sorting this string, what I did is, I just went through all the permutations of this. Yeah. Okay, so I went through all the permutations of this. I kept a vector of strings that I will print. I kept the best answer. Okay. Now, whatever string that I have right now, wait, I need a copy as well. So let's say string t equals s. Okay. So whatever string that I have right now, what I will do is I will try to find the answer for this thing, s and t. Okay. Now, if this answer is like, if this is greater than the best, then I will just say pr.clear and best equals temp. Finally, if temp equals best, then I will pr.pushback s, something like this. So what I'm trying to do is I'm trying to print all the strings that give us the minimum answer, then print all the strings that are present in this PR. Yeah, so that's what I did in this problem. I mean, that's at least what I try to do, and trying to print all the strings that work, right? So let's try any string for now. Like, we just need 4 different characters, right? Because I haven't used a and t o anywhere. So let's take something like this, right? So we get this answer. Let's take some other string, like I don't know, something like this. So yeah, so then you get this answer or whatever. So what I noticed, like a pattern, is that usually, like almost like, I'm sorry, this is just like a guess, but I guessed that um, if there's a solution, there will also be a solution in which all the similar characters are like next to each other. So you can see that all m's are together, all b's are together, all n's are together. So like no matter what string you give input, there will be either no yeah, so there will be at least one answer in which like all are next to each other, like I don't know, a n a n t t o n a, something like this. So you can see that usually, like even if you're getting multiple answers, at least one of them is something like all the characters are together, like all the similar characters are together. So yeah, so I just I kind of also tried to prove it a little, but couldn't really do it. I was also distracted, so I just guessed. I went with my guess, and then I removed this part. After that, I wrote this part. So what I'm doing here is I am finding the count of each character. I'm taking a and to in a vector, sorting it, and going through all the 4 factorial permutations. 4 factorial possibilities, right? So going through all the 4 factorial possibilities, making the string accordingly depending upon the permutation of this thing. And yeah, so if that string gives me the best answer, I'm just storing it and just printing the best string. So that's the code that I submitted. That's exactly the code that I submitted, in fact. And it did pass pretest, but I think it was like really difficult. Or I think I was distracted or something. But yeah, so that's the end of this video. See, let me see the rank once again. Must be 150 or something. I'm standing 144. Yeah, around 150. Yeah. So anyway, okay. So yeah. So the problems. Sorry. The problems C and B required, I think, modular arithmetic and segmentary. Right. So I'll just put the links to those lectures that I've done earlier in the pinned comment, and you can check them out. So thank you for watching, and I'll see you next time.